Hi everyone. In this class, I'm going to explain about AM wave frequency representation or the spectrum representation, bandwidth of the AM wave, and the transmission power required to the AM wave. So, these two are the very important one for any communication system. Bandwidth and the transmission power. So to do these three parameters means to find these three, we need some requirements. That should be some mathematical expressions, means some mathematical formulas, and the frequency shifting property of the Fourier transform. Fourier transform would be used for the transmission of, means changing the analog signals into ఫ్రీక్వెన్సీ సిగ్నల్. అంటే ఎనలాగ్ డొమైన్ నుంచి ఫ్రీక్వెన్సీ డొమైన్కి కనుక చేంజ్ చేయాలి అని అంటే ఫోరియర్ ట్రాన్స్ఫార్మ్ యూజ్ చేస్తారు, మీకు తెలుసు. సో అండ్ వన్ మోర్ థింగ్, ఐ హ్యావ్ టు నో మ్యూ ఈజ్ ఈక్వల్ టు కేఏ ఇంటూ ఏఎం. Here mu is equal to modulation index over R depth of modulation or percentage of modulation. How we can define the modulation index? Modulation index is maximum modulus of some sensitivity parameter product of the m of t at max. We know that m of t is the message signal. M of t is the message signal. It is equal to am cos 2 phi fm of t, where I am substituting this equation in the modulation index. Ka am into cos 2 phi fm of t max. These two are the constant terms, we know very well. Here I am taking it as the theta, it is the cos theta. Cos theta maximum to minimum values. Cos theta existing from +1 to -1. So mu of Ka into a suffix m of 1 for the maxima. Therefore mu is equal to Ka into am. Modulation index, how it came? As like it came. This is the matter of mu. Next, what we require? Another requirement for this mathematical calculation. Transmission power formula we have to know. V square RMS upon R over R means this one. I square RMS into R. Our formula. Vrms is equal to V peak to peak upon root 2. It require these two formulas have to remember for the calculation. Another one, 2 cos A cos B is equal to cos a plus b plus cos a minus b. 2 cos a cos b is equal to cos a plus b plus cos a minus b. These two are the equations we have to remember. And another one, Fourier transform of a cos theta or a cos 2 phi fct is equal to a upon 2 del of f minus fc plus del of ef plus fc. This is the Fourier transform of a cos 2 phi fc. If we substitute at AC fc place f minus efc plus fm, what happens? What we substitute at in the if we substitute at fc efc plus efm, it will come here. If we substitute in place of efc minus efm, that fc is replaced by fc minus fm. That is the basic formulas for that one. I'm going back, and the one more thing and the last, we have to remember that modulating signal of AM wave. What is that modulating signal? AC cos 2 phi fct plus Ka into AC into m of t into cos 2 phi fct. This is also have to remember for that one. For what purpose? To find the spectrum of AM wave, bandwidth of AM wave, and transmission power of that AM wave. Okay, frequencies representation or the spectrum representation of AM wave. First of all, what is AM wave? SAM of t is equal to AC cos 2 phi fct plus Ka AC m of t cos 2 phi fct. In the above equation, we know the value of this value m of t is equal to AM cos 2 phi fm of t. I am substituting this m of t in the SAM of t. Then SAM of t become cos 2 phi fct plus Ka into AM into AC into sin 2 phi what is this value? Cos 2 phi fm of t into cos 2 phi fc of t. We have to remember that this is the modulation index. AC cos 2 phi fc of t plus Ka AM, that is equal to Ka AM is equal to mu. I am writing AC, I am multiplying and dividing with 2. Then remaining will become a 2 cos 2 phi fm of t cos 2 phi fc of t. Then this term is as it is plus mu AC upon 2 2 cos 2 phi fc t plus cos 2 phi fm of t. This is the equation. It I am taking as b, it's for a, it is taking as b 2 cos a cos b, 2 cos a cos b. 2 cos a cos b is equal to this term as it is mu ac upon 2 is equal to cos a plus b. A plus b means 2 phi fc plus fm of t plus cos a minus b 2 phi of fc minus fmt. I write directly, you may understand that one. This term is as it is. I am applying Fourier transform here. What will happen if we apply Fourier transform on both sides? This will become a SAM of f is equal to Fourier transform of AC cos 2 FCT is equal to AC by 2 into del of f minus fc plus del of f plus fc. This is equal to corresponding to carrier signal. What about remaining two terms, this term and this term? Then plus mu AC upon 2 into, again 2 will come in the denominator for this one. I already discussed that the formula. What is that formula? I will show you. What is the equivalent of this one is equal to a upon 2 into this function, whatever the modulation index. So in that way, here there is no upon 2 AC upon 2 K. Here also these terms is there. For this one there is denominator 2, but this one denominator 2 I am taking as common. Mu AC upon 2 into 2. Then what happen? Here in the cos place fc plus fm is there. Here in this one fc minus fm there. In this one, first fc is here replaced by fc plus fm. For this term, fc is replaced by fc plus fm. For the second term, fc is replaced by fc plus fm, fc minus fm. What happened that function? Whatever that function is there, what happened there? We will see and observe that. Finally, for this first term, the equation will become a del of f minus fc plus fm plus del of f plus fc plus fm. It is the first term. For the second term, plus del of f minus this fc plus fm is replaced by fc minus fm plus this fc plus fm replaced by del of f plus fc minus fm. This is the equation. I will write in detail. This is equivalent to the first term. This is equivalent to the second term. This is equivalent to third term. I am writing the spectrum corresponding to this equation. How it is look like there. I am taking here amplitude, and the direction I am taking frequency. For the first term, there is a, this is the parameter. This is equal to, I am taking, yes, it is carrier component. The amplitude of this one is equal to AC by 2. This is also AC by 2. That is the carrier component. This term indicate Fc plus Fm. This term indicate Fc plus Fm. Here the plus and here the minus. What will happen? One indicates the upper side band, another one indicates the lower side band. Minus of Fc minus Fc plus Fm. It is the minus Fc, it is the Fc. Fc plus Fm, it is the Fm. It is, this point is equal to Fc minus Fm. This is also minus term. Here it is the Fc. This is equal to Fc plus Fm. This is equal to Fc minus Fm. This is equal to minus Fc plus Fm. This term is equal to this one, as well as this term is equal to this one. It is the lower side band. It is the lower side band. It is the upper side band. It is the upper side band. What is this? This is the upper side band and this is the upper side band. It is the lower side band. It is the lower side band. What is the amplitude? That is the amplitude of the upper side band and the lower side bands. This is AC mu by 4. This is also AC mu by 4. This is the, what are those? That one. That particular things is there. Those are the powers and the amplitudes of that one. I am talking about the, what I am talking, my aim is I have to find the frequency bandwidth, and it is the spectrum representation. What I have to find? I have to find the bandwidth of that particular signal. I am taking this side only, positive axis side only. I am taking this one. It is the carrier Fc. It is equal to Fc plus Fm. This is equal to Fc minus Fm. It is upper band frequency. It is the lower band frequency. It is upper limit. It is the lower limit. It is the upper limit. Bandwidth is equal to upper minus lower band. Upper band minus lower band. Fc plus Fm minus of Fc minus Fm. Therefore, Fc plus Fm minus of Fc plus Fm. What will happen? Fc get cancelled. It is equal to 2Fm. What is this, Sunday? Bandwidth. Bandwidth is equal to 2FM. Next, what I have to find? I have to find transmission power. What I have to find? I have to find the transmission power. Transmission power PT is equal to P carrier plus P USB plus PLSB. What are those, Andy? P carrier plus P USB plus PLSB. What is the carrier amplitude? AC upon 2. What is the PUSB upper sideband amplitude? Mu AC by 4. It is also mu AC by 4. How I can calculate power? Power is equal to V square RMS by R, which is already discussed in starting class. Then from this one, Vrms we don't know. Vrms is equal to V peak to peak upon 2. It is for the only one peak. Peak to peak means it will be doubled and it will be doubled. Therefore, I am finding the carrier power. Carrier power means Vrms, V peak to 2. Actually, it is for the normal one. It is for the one peak, means upper one. Peak to peak, it will become a amplitude is equal to AC. So here Vrms for carrier, Vrms is equal to AC upon root 2. కానీ I need to find నాకేం కావాలి V square find out చేయాలి. So I am squaring on both sides A square by 2. Then I am substituting this A square by 2 in this equation PC. Therefore it will become a AC square by 2R. What is this? It is the carrier power. What is the carrier power? AC A square C by 4R. I will explain again, no need to worry. P is equal to V square RMS by R. Here I am finding the carrier. Carrier peak to peak voltage is equal to AC. Vrms is equal to, what are the two? Peak to peak upon root 2. So root 2. Here square is there. I am keeping square. Then AC square by square root get cancelled. AC square by 2. I am substituting this value in this equation. Then it will become is equal to AC. PC is equal to AC square by 2R. Now I have to find PUSB and PLSB. I am finding the PLSB. Oh, so V square RMS upon R is one of the formula. V RMS square, V square RMS is equal to V peak to peak. One peak value of the USB is equal to V peak, normal peak is equal to how much? Mu AC by 4. Peak to peak will become a mu AC. Wait. 4. Then V peak to peak is equal to mu AC by 2. It is normal one. It is half part. Full part is equal to, it will be double. 2 get cancelled. Mu AC by 2. Therefore, V is equal to what? VPP upon root 2. Then Vrms is equal to mu AC by 2 root 2. I will get that. I am going to squaring on both sides. What will happen? If I square on both sides, mu AC square by 8, I will get that answer. But I need USB V square RMS by R. I am substituting this V square RMS in the PUSB. It will become a Pu USB is equal to mu AC square by 8R. So how could I write? As well as here the PUSB amplitude and PLSB amplitude will be same, then PLSB is also equal to mu AC square by 8R. How can I write? How can I change this one? I am writing like this: mu AC square by 2R into 4. This AC square by 2R is equal to what? AC square by 2R is equal to carrier power PC mu by 4. I will take another page. Pu USB is equal to mu AC square by 8R square, I think. Yes, 8R. Mu square also, it also squaring for this mu also is there, or for this one. Yes, this is also get cancelled. This is also will be squared. Okay, now this is also square. Then it will become a mu square AC square by 8R. I am writing this as the two parts. Therefore, mu square upon 4 into AC square upon 2R. This term equal to PC. Where I derive that one, I will show it to you, right? This is the carrier power AC square by 2R. So simply I can write this PC mu square by 4 for the PUSB. Then PLSB is equal to PC mu square by 4. Therefore PC is equal to, what I write that, AC square by 2R. All those are the equations for that one. So PT is equal to PC plus PC mu square by 4 plus PC mu square by 4. PC mu square by 4 plus PC mu square by 4. Quarter plus quarter is equal to half. Then PC plus PC mu square by 2. Total power. I am taking in this one PC is common. Then this total transmission power PC is equal to 1 plus mu square by 2. It is the transmitted power. What is this? Transmitted power. And efficiency of AM modulation is equal to power of the sidebands upon total power. Power of the sidebands is equal to what? Power of the sidebands is equal to PUSB plus PLSB. What is PUSB value? PC mu square by 4 plus PC mu square by 4. Therefore, this one is equal to PC mu square by 2. It is the PSB. Therefore, efficiency is equal to PSB by sideband power by PT. Then PC mu square by 2 whole divided by PC 1 plus mu square upon 2. Then this PC get cancelled. then it will become a denominator I am taking as LCM. It is mu square by 2. After it is the 2 LCM, 2 times will be cancelled, therefore 2 plus mu square. This is the equation. 2 get cancelled. This one is equal to efficiency is equal to mu square plus 2 mu square. I am going to summarizing this session. What we discussed in this session, spectrum, what we draw the spectrum of that one. This is equal to, it represents the EFC. This is also represents the EFC. This carrier, what is amplitude, is equal to AC by 2R. It is the lower side band, it is the upper side band, it is the lower side band, it is the upper side band. This is the EFC. It is this point minus Fc plus Fm. This point is equal to minus Fc minus Fm. The what is this amplitude? This one is equal to AC mu by 4. This is also is equal to AC mu by 4. It is Fc plus Fm. It is Fc minus Fm. The upper limit minus lower limit is equal to, means Fc plus Fm minus Fc plus Fm, then is equal to 2Fm is the bandwidth is equal to 2Fm. We find it and we draw its spectrum. Then carrier power transmission, transmitted power is equal to carrier power plus upper sideband power plus lower sideband power. Power is equal to V RMS square by R is the formula. So I got PC is equal to carrier power AC square by 2R. P USB is equal to P USB is equal to P LSB is equal to AC square mu by 4R. PC into mu square by 4. After substituting these equations, finally I got PC is equal to PC 1 plus mu square by 2. And I find the total. This is the total, and I find the efficiency P sideband power upon the P total transmission, that is equal to mu square upon 2 plus mu square. In examination point of view, how the question framing will occur. This is the one formula. It is the another formula. It is for the what is the efficiency. It is for the transmitted power. If PC carrier power is equal to 10 watts, depth of the modulation is equal to 50%, what is total transmitted power? That is the question. You can, by putting these two values in this equation, you will get the answer. That is not a matter. If the depth of the modulation is equal to 25, you may frame the question if the depth of the modulation is equal to 10. Otherwise, if the depth of the modulation is equal to 3%, then find the efficiency. We know that efficiency is equal to mu square plus 1 plus mu square. By substituting that to 9 by 1 plus 9, 9 by 10, that efficiency is equal to 0.9. It is the question framing way. There is another in terms of current and voltages, how you can frame the question. PT is equal to PC into 1 plus mu square by 2. We have a formula for that one. What is that? P is equal to I square R. There is a formula. IT square R, then PC is equal to IC square R. By putting these two equations here, what will we get? That transmitted current is equal to carrier current into 1 plus mu c square by 2. Because of RR get cancelled. In terms of voltage, total transmitted voltage is equal to carrier voltage square into 1 plus mu square by 2. I can mention that the transmitted total, to find the total transmitted current, the carrier current is equal to something and the depth of the modulation is something. Find the total transmitting voltage, therefore the depth of the voltage, the depth of the modulation is something and the carrier voltage is something. This is, thanks for the watching, keep smiling. ఏమైనా డౌట్స్ ఉంటే కామెంట్ సెక్షన్లో పోస్ట్ చేయండి. థ్యాంక్ యూ సో మచ్ ఫర్ ది వాచింగ్.